Hello folks. It's a bit chilly in the barn this morning, but we don't care about things like that because we have some serious Volkswagen, or they say in German VW, chargers to hack. So when you last saw us, we were only able to run the charger by playing back CAN messages from a log file. Now, thanks to some very talented people over on my Patreon channel, we were able to, well, one person in particular was able to hack the kind of fancy CRC that Volkswagen use on there for their CAN messaging. And we now then found ourselves in a position to be able to send our own CAN messages to the charger. And because we can do that, now we can write programs and start to screw up in all more interesting ways. So let's go have a look here on the bench, and we will show you what we've got going on, and come back then, and you can basically, you know, either laugh at me or tell me how brilliant I am, or none of the above. Alrighty folks, let's have a little bit of a walk through here and we'll try and show you what it is that we have set up. So as before, we have our Seat Me charging socket. We have our plug present and control pilot wires hooked from this to the charger. We've also got our lock and our lock feedback. So these four wires here connected from the charger to the locking mechanism, which is on the far side of the Me charging port. Plugged in, we have just a Type 2 granny cable, 10 amps maximum AC current. Sitting up on top of the little bottle here, we just have an RGB LED, which you have on most charging ports these days, that is just telling us, I guess, the status of our charging. Here we've a 1.1K resistor that is wired in place of the charge port temperature sensor. So it's just basically fooling it to thinking it's around 15 degrees centigrade. So here in the middle, we have our Volkswagen PHEV charger. This is from a Golf, I believe. So this isn't the battery electric Golf. This is the plug-in hybrid variant. We can tell that by the fact that it has these cooling pipes on the top instead of on the side, apart from checking part numbers or anything like that. The front of the charger, our single phase 230 volts AC coming into the AC input from our, again, Seat Me charging port. We have an earth wire from the charging port just directly connected to the charger's casing as well. I've removed, as I think I described in the previous video, this kind of a multi-way block thing where they had all of these fancy DC connections, and we've just got ourselves some wires put on here with quick connects, and at the minute those wires are just coming over here and they're going to this electric cooker heating element, which is just working as a dummy load for the charger. I've got a multimeter just on DC current, just measuring the DC current that we're putting in. From the charger then, obviously we have 12 volts DC just being supplied here from a bench power supply. It's a little bit over to my left. Here we have our hybrid CAN and our powertrain CAN from our charger. Now, one of the big things so far that I've managed to discover is that the charger has no problems with the hybrid and powertrain CANs being connected together. which I have done in this kind of multi-way block here. So this means that we don't have to have two separate CAN channels, as I had in the previous video when I was doing some playback tests. So right now, a lot of CAN wiring going along here. Let me just pin it down a bit. So, well, let's not. So, our charger, from a hardware point of view, is reasonably straightforward here in that, just to recap, 12 volts, CAN high, CAN low, and our charge port connected in, AC from the charging port, DC to the high voltage battery. So, getting the charger to run and getting it to produce current for us is where my focus has been about the past week, 10 days with this thing. It's been a slow slog because there's very little information out there on Volkswagen CAN data. Very little data on the CAN data. So it's kind of, a lot of it is kind of working from first principles, which is incredibly slow. But we have managed to get a little bit of a milestone insofar as that instead of just running the charger here via playbacks, we now have a little bit of software running on an Arduino DUI here that is very roughly and very crudely able to switch on the charger and get it to produce current for a few seconds, which I will demonstrate shortly. Now, the problem that we have is that there are a lot of cross-checks in the CAN communication here. And I'll get into some of that shortly also. But what it means is that the charger is looking to verify that what it's doing is being reflected by another module, in particular the battery management system. So the fact that we can get it to produce current at all, even for a few seconds, means that I actually had to work through quite a few cross-checks. But there's still a few left, and they're getting me. So I'm working away on that. Second problem then that we have is more of a hardware one instead of a software one. And that is that we're still kind of wedded to our Seat Me charging port here, because I have to work out a little hardware circuit to basically fool the charge port lock system so that it will believe that it has locked the port. And once we can get that working, we'll then be able to look at using it with a non-Volkswagen charging port. It's a little tricky the way they do the sensing here. I'm not 100% sure that the Seat port is the same, uses the same kind of sensing as the Golf hybrid port. It does work, but it just looks to me for some reason to be a little bit odd, the way that it works, but that could be just because I'm not familiar with it. So I've been messing about with a little potentiometer on that here, trying to get it to, I guess trying to fool it even halfway, even to think that it's locked, fully locked or fully unlocked before we can put it into the mechanism. But the good news is I did manage to find another CAN message that I was missing that it does need to see in order for it to cycle the locking system. But anyway, enough about that. Boredom, you say. Let's see this thing give us some current for a few seconds. Now, before we do that, a little bit more boredom. Folks might say, well, the reason it's shutting down is you're just pushing current into a resistor instead of the charger wanting to see a high voltage battery. And indeed, I have, I thought of that one myself. And I had a demo cable here, and I have a way to connect to the Land Yacht's high voltage battery. We've been basically testing it with both the high voltage battery, 360, 370 volts DC available here, and also testing it just with a resistance dummy load. And this charger, from best that I can tell, does not care what's connected to the DC high voltage output. It can charge a 360 volt battery, can charge a 12 volt battery, or it can charge a heating element. The errors that I can kind of see, or the patterns in the CAN messages that I can see, whether I'm getting a failure with the heating element or getting a failure from the high voltage, pretty much remain the same. So that's it. Let's fire this little guy up. All right, so the way I'm going to be doing this is I'm going to let you guys see the multimeter here and the charging LED here, and I'll be just using the laptop and the DC power supply here to initiate charging. So I'm going to turn on the 12 volt supply. You'll see the LED come on, then I'm going to initiate charging. The LED will start pulsing blue. You'll hear the charger start, ramps up to about 5 amps. It should now fail. And there it goes. It actually got a little bit further that time. And that's it. I'm not able to restart charging via CAN because the charger has now entered some kind of a failure mode. So it won't matter if I try to restart here via the little interface I have on the Arduino here. It won't really do anything for me. And if I want to restart, I have to basically cold boot the charger. So turning the 12 volt power off, and then we can go again, we can turn on, and we can re-initiate charging. And there the charger spins up, pumps about 5.5 amps into our load for actually quite a few seconds, and then errors out. So I have several CAN logs of tests like this, and I will definitely put some of those CAN logs up on the GitHub. There'll be a link in the description for anyone that wants to play along. Also here I'll put up my little Arduino sketch. It's got a super crude and simple menu on it here that just lets me start and stop charging. And there's quite a bit in there for the CAN that I've worked out so far. So again, maybe folks can kind of look at that and maybe figure out that I've done something stupid, which is always entirely feasible. Ultimately, we want to have this guy working, not just with the little Arduino here. Let me pan you down to that, get a better look. So this is just a board. This is one of my generic boards I had from something, but it's just a SAM3X80, which is an Arduino DUI processor and a CAN transceiver. So that'll be one option for running these VW, as we'd say in German, chargers. And obviously then as well want to be able to run it with our Zombieverter VCU. And then with our Seat Me charger that we need to have a look at. Oh, in case I didn't mention, the Golf plug-in hybrid charger is a 3.3 kilowatt. I have verified that here experimentally by using a 32 amp charging point connected here, and it does indeed then ramp up with a 360, 370 volts, about 8-9 amps of current on the DC side. So we're definitely at a 3.3 kilowatt charger here with our plug-in hybrid. Then when we go to the battery electric vehicle variant, pan this away. We go to the battery electric vehicle variant, we get up to 7.2 kilowatts in these, which are roughly the same size, a little bit bigger than the Golf hybrid, and can also tell those by the fact that they have the cooling ports on the side rather than on the top. That is another version which is in some of the more advanced Volkswagen brand cars like Audi e-tron. I think has one of these that is a 3-phase 11 kilowatt charger. Very pleased to say that thanks to one of my patrons over on Patreon, I have one of these Audi e-tron 3-phase 11 kilowatt chargers on the way to me. So pretty soon we'll have all three, and we'll hopefully then be able to get all three variants of this charger working both with our VCU and just with a simple Arduino program for folks that don't need all the VCU bells and whistles. So that is a very, I guess, not very quick overview of our progress so far with the, I guess, the hardware and the CAN hacking and the various other angles here of our Volkswagen chargers. Alrighty, so thought we'd just have a quick look at the raw CAN traffic here using SavvyCAN. Sorry that I can't do a window record here. It's just the last time I did that, some people said that they couldn't see certain things, certain windows weren't been visible with the recording, so probably need to spend a bit of time figuring that out, but just for this it should be pretty straightforward. So the first of all, what you see here on the window are the, I think, 8 messages that we need to send to the charger, at least the 8 messages that I know of at the minute that we need to send to the charger. So in no particular order, they are 97, 6A4, 6A3, 187, 3A6, 3AF, 489 and 124. 97 needs to go at 10 milliseconds, 6A4 and 6A3 go at 500, and 187, 3A6, 3AF and 489 are 100, and 124 needs to go at 20. Now you'll see over here that there's all kinds of jitteriness and maneuvering going on. That is because our VW engineers have typically a counter in the lower nibble of byte 1, which counts from 0 to F. And then they have this CRC with a little bit of magic in it. That's in byte 0, that's calculated from both the counter, the content of the message, and another thing called a magic byte. So if you're interested in that, you'll see a good bit of that in the Arduino sketch on the, what's the name of it? On the GitHub repo. So at the minute, because our charger is switched off, we're only seeing the messages that our Arduino sketch is pumping out here. Now, of all these messages, the only one that I've any bit of official or semi-official info on is 187, and that because was documented on the OpenDBC on the Comma AI repo as being the gear shifter indication from the car, and that I guess has to be in park for us to be able to commence charging. There is a ramp in some of those bytes, in the later bytes in 187 that I have simulated. But as to whether or not that has any impact on the charging process, I can't at the minute tell. 97 and 489 are, to the best of my knowledge, BMS messages. I think 97 contains battery current and voltage. I have managed to work out some of those just from CAN logs. And by the way, I want to thank people who provided CAN logs, because they are most definitely the bread and butter of any of this process. So now what I'm going to do, just for fun, I'll kick the 12 volts on to the charger. I won't try and start a charge, but it'll just show you the messages that'll pop up here when we switch the charger on, and there's quite a few of them. I've pretty much zero understanding of any of the extended IDs. They're generally slow. They're like 1 second, 500 milliseconds, like that. That's a 1 second message there. Some of these I have managed to figure out a few of the things like the AC voltage and the DC voltage and that. And Tom Debris actually did quite a bit on that. And has the beginnings of a DBC file for some of these messages as well up on the repo, which I must grab now and actually put in some of the things that I've found out. I just got myself really busy over the last couple of days with a more pressing problem, so I haven't been back to the whole Volkswagen charger situation until now. But this is what we've got. There's a mixture of messages with both extended and standard IDs in them. And there's one or two of the ones with the extended IDs that seem to have variable lengths. Like this one here changes from DLC of 3 up to a DLC of 8, which I don't think I've seen messages doing before. Which is quite interesting. If I were a guessing man, I would say that is quite possibly an error matrix or an error log or something like that, which would be really great to know what they mean, because then I could figure out why Mr. Volkswagen is being angry with me in the first place. But anyway, that's just a very quick look at, not very quick look, at the CAN, which I thought you might be interested to see. But I'll have logs of these sessions up there on the repo, all done with SavvyCAN, which is a free and open source program. And so if you're interested in having a look and maybe getting involved with the project, do have a look at those logs. So folks, might as well get the shine on the skull. That is about it for our Volkswagen charger at the minute. Got to keep looking in there to see what I can figure out about the interlocks in the CAN and also the hardware side with the charging port, because we don't want to be wedded to just using a Volkswagen charging port. So I'm going to keep at that. I'll ask again, particularly if folks have want to help out, if they've any access to Volkswagen cars like the Seat Me, e-Golf, and particularly now the Audi e-tron, because we're getting that 11 kilowatt 3-phase charger, and you would like to do some CAN logging for me of your charging sessions, that would be much appreciated. So that's about it. I'll keep working on this stuff. You folks, as always, give me that thumbs down. Don't subscribe. If you are subscribed, unsubscribe, because we do not want to accidentally reach that 25,000 subs. As usual, also, do check the links in the description to Patreon and PayPal in case you want to financially support this stuff. But no, don't do that. It'll be Open Inverter Forum, GitHub, anything else. Dallas EV Repair, Good Enough Garage, anything else I can think, I'll just pile in there and you can have a look through them. So that's it. I gotta go get some lunch, and then I'm going to get back to some of this charger hacking. And until we see you again, happy Full Egg Wertlos Ledergerät.